in this exercise here, we will use the complex conjugates pairs theorem to find all the complex zeros of a given polynomial function. And then you write the polynomial in completely factored form. Well, what do you mean by complex conjugate pairs theorem? So this one is just saying that if I is a root, then its conjugate is also a root. So if A plus BI is a root, then A minus BI is also a root. So they always comes in pairs. Okay, now to find all the zeros, all complex zeros, that means all the zeros including the complex zeros, rational, irrational, and then complex zeros. So to do that, first, it's important to look at the degree of the polynomial. Since the degree here is 4, then we should expect 4, including multiplicity. So you expect 4 roots, including multiplicity. So we first get the possible rational roots. So you can have P over Q. So your P's here are the factors of the constant term. So that's 1. And your Q, the Q's here are factors of the leading coefficient, which is 6. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. These are all the factors of 6. Then you get P over Q. P over Q will be plus or minus 1, plus or minus 1/2, plus or minus 1/3, plus or minus 1/6. Now, these are all the possible rational roots. Now, our goal is to just check maybe one, at least if we know, in this case, we should know 2 because we want the quadratic. We want to reduce it into a quadratic factor. So you can use factor theorem to check which ones here are factors, or you can use a graphing calculator. So if you use, for instance, a graphing calculator, I use Desmos calculator here. So I graph the function, and this would be my graph. So now from here, I see that I look for rational root. Okay, so I have 1 here as my root. So all those with decimals, I have to be very careful because they might not be exact. So I'll use first 1. And then also, since if you look at the graph here, it touches at 1. So the graph just touches x. The graph just touches the x-axis at x equals 1. So that means that 1 here is of even multiplicity. So I'll check for multiplicity. So let's go back and do this. So let's perform synthetic division here. So you have 6, negative 11, 3, 3, negative 1. Then I'll do 1. So I have 6, multiply 6 by 1, positive 6. You add this 2, you have negative 5. And then negative 5 times 1 is negative 5. Add negative 5 times 3. Negative 5 plus 3 is negative 2. Negative 2 times 1 is negative 2. Add negative 2 plus 3 is positive 1. Times 1 is 1. So we got 0. Now we check for multiplicity. So we divide again by 1 because we know when we graphed it, it touches the x-axis at 1. So it touches the x-axis. So that means that 1 is of even multiplicity. So We perform again another synthetic division. So you have 6, bring down 6 times 1 is 6, positive 6. And then negative 5 plus 6 is positive 1 times 1 is 1. That's negative 1. So negative 2 plus 1 is negative 1 times 1 is negative 1, 0. Now we're able to find, so here we have 6x squared plus x minus 1 equal to 0. Those are that's the quadratic factor. So to find the remaining 0, we will use the quadratic formula. So we have x is equal to negative b, so negative 1 plus or minus the square root of, so you have the square root of b squared. This is your b. The square root of b squared, so 1 squared minus 4. A is 6. Your c is negative 1. All over 2 times 6. Then you simplify. So again, double check first. So that is square root of b squared minus 4ac. So 4 times 6 is 24 times negative 1. So negative 24 times negative 1 is positive 24. Plus 1 is 5. So you have here negative 1 plus or minus square root of 25 divided by 12. So now the square root of 25 is 5. So we have negative 1 plus or minus 5 all over 12. So negative 1 minus 5 is negative 6 over 12 is negative 1/2. Then the other one, you have negative 1 plus 5 is negative 4 divided by 3 is, positive 4 divided by 3 is 1/3. So these are all the roots. Okay, so this is using the quadratic formula. You can also factor if you want to. So you can factor this. What are the factors? So or I say factor. So it depends on what is more convenient for you. So you can factor 6x squared plus x minus 1 equal to 0. Whether you factor or you use a quadratic formula, you should get the same answer. So you have 6. The factors of 6 will be 3 and 2. So you have 3x, and then the factors of 1 is 1. So we'll reconcile the sign later. So you have 2x, and then you put 1 and 1 here. Now, which one gets the positive? So this one is minus, because if you multiply this and this, that should be negative 2. And then 3x times 1 is positive 3x, because you want the middle term to be positive. Those are the factors. So from here, you're also able to solve that x is equal to 1/3 or x is equal to negative 1/2. So that's the solution set. The solution set contains 1, negative 1/2, and 1/3. Now it's asking here to write the polynomial in its completely factored form. So polynomial in its completely factored form. So what is your f of x then? F of x is equal to, so these are all our roots. These are all our roots. So you have x minus 1. Now that's multiplicity 2. And then you have x. You can also write this. So you have 2x plus 1. That's for the fraction. So 2x plus 1. And then this is 3x minus 1. So that's the completely factored form of your polynomial.